Welcome to Section 2 in the Learning Microsoft Azure course, in which you will learn about implementing a virtual machine architecture. This section is mainly about virtual machine architectural design, followed by giving you some guidelines for deploying your first Azure virtual machine, which I'll show you in an easy demo. Once your first virtual machine has been deployed, we're going to make it a little bit more complex, more advanced, and then walking you through the deployment of a more complex virtual machine solution. And then in the end, talking about handling virtual machine high availability. In this first video, it will all be about Azure Virtual Machine architectural design, making sure you understand the underlying infrastructure of the Azure platform that is required for deploying Azure virtual machines. In this video, we're going to take a look at Azure Resource Groups, Azure Virtual Networks, Azure Storage, and Azure Virtual Machines. When we take a look at the logical architecture of an Azure virtual machine, it all starts from the top, mainly starting from your Azure subscription. Within an Azure subscription, you can define multiple Azure resource groups. Now, there are some limitations on the number of resource groups you can deploy, but overall, I shouldn't focus too hard on any limitations. Today, there are no real limitations that you have on the number of Azure subscriptions you can define. So don't worry too much about those limitations. If you're really interested, if you're managing like an Azure enterprise environment, I suggest you to have a look at the documentation and then zooming in from there how to manage your subscriptions. Now let me share a little bit more about those Azure subscriptions. Within a subscription, you create a resource group, where an Azure resource group is always linked to a specific Azure region, where again nothing really blocks you from deploying Azure resource groups or multiple resource groups and the number of resources within the resource group. In different regions within a specific resource group, you define a storage account, since a virtual machine requires a VHD file, or even multiple ones, depending on the number of disks you want to link to a virtual machine. And the storage account will be linked to the Azure storage account. Once you have your virtual machine, we're going to define computing virtual machine size information, configuring virtual disks, and defining virtual networks and subnets. So let me start with the basics. Azure resource groups. An Azure resource group is a single unit. It's like a logical container within Azure Resource Manager. It doesn't exist in Azure Classic, which is being used for centralizing Azure resources that somehow belong together. A virtual machine depends on storage and on a virtual network. A virtual machine might even be made public if you want to provide like a direct remote desktop connection to the VM. All the different Azure resources will be grouped, centralized in all those Azure resource groups. And again, can be a single one, can be multiple one. Resources can also be shared among Azure resource groups. Azure resources are always deployed within an Azure resource group. So it's like a top level for creating and provisioning Azure resources. An Azure resource group also acts like a boundary for your deployment and helping you in organizing your resources and controlling them by using a mechanism that's called role-based access control, really allowing you to limit the admin access rights to those specific Azure resource group or even up to individual Azure resources. Now, sometimes I do get a question, can you share any guidelines on how to organize my resource groups? Now, I'm really sorry, but it's really up to the customer, up to the partner, to outline the structure of your subscriptions and your Azure resource groups. It depends on the complexity of the organization, the size of the organization, the number of application workloads you have, and there might even be administrative requirements on how to classify and create your resource groups. One level down, it's all about creating an Azure storage account. An Azure storage account is a logical boundary for storing Azure storage components, which basically is based on 4 different storage types you can deploy. The most obvious one is using virtual machines, is defining block storage, as it can also be used for storing images, documents, typical files, and obviously also VHD files. Besides block storage, we also have Azure File Shares, which, as the name suggests, allows you to create Azure public file shares. Besides those two, Azure storage accounts also provide a stable storage and queue storage, which will be covered later on when I'm talking about applications. Now, coming back to virtual machines, we talk about block storage, which exists in three different flavors: standard storage, premium storage, and cool storage. Standard storage provides you the location, the unit to configure virtual machine disks, where each disk gives you an average of 300 to 500 IOPS, which points to the performance of one single disk. A disk within Azure can have a maximum size of 1 terabyte. It can be linked to most virtual machines, and standard storage is based on typical hard drives, so real physical disks which are being presented as virtual disks to your virtual machines. The second storage type we have is premium storage. In short, premium storage is all about performance. It's giving you anything from 500 to 5000 IOPS, where again a disk can have a maximum size of 1 terabyte, and instead of being in the typical hard drive, it's always based on SSD solid-state disks. So again, performance is key. The last storage type is cool storage. It's not about performance, it's about providing low-cost storage. Cheap storage. It's mainly used for storing long-time archived data. Typical use case examples here are virtual machine images that are there but not always used, or using this one for storing media content like image files, JPEG files, whatsoever, or even using it as an archive solution. Another critical component that is required before we can actually deploy the virtual machine is using Azure Virtual Networks. A typical network service we have is using automatic or fixed IP address. Now, one of the questions or discussions we have in Azure courses or trainings is, why is everything in Azure pointing to an automatic IP address? Well, it's pretty easy. It's all about managing your infrastructure as a service. So Microsoft Azure itself is a physical data center. But then on top of that, in the full Azure stack, it's difficult to create your own physical networks. So that's why we're relying on virtual networks. And virtual networks allowing you to create your own subnets. So the recommendation out of Azure Networks is using automatic IP address mapping. But at the same time, I have to mention that nothing really blocks you from defining your own fixed IP address. Another service that we have available out of Azure Virtual Networks is DNS, as well as virtual private networks, site-to-site VPN, connectivity point-to-site, from like one station, like an admin or developer computer, or the third one, ExpressRoute, which is a dedicated direct connection from your enterprise network to Azure data centers. Another interesting service that went live a couple of months ago is VNet peering, where VNet peering allows you to glue two virtual networks together, even if they're in different Azure regions or within different Azure subscriptions. It's basically giving you the same functionality as a typical on-premises load balancer for load balancing traffic, allowing you Azure load balancers. On top of that, you could also use load balancers from the marketplace, injecting third-party load balancers. And then one of the last components talking about virtual networks is security of your network traffic, which is possible by using network security groups, allowing you to specify software-based firewall rules where internet-based traffic, for example, can be blocked off, or even internal traffic between virtual networks can be allowed or being blocked. The last item when talking about virtual machines is computing power. Whenever you deploy a virtual machine, by using the portal, by using CLI, command line, or PowerShell tools, even from Visual Studio as I showed you before, you always have to specify what's called the virtual machine size. Funny enough, a lot of Microsoft people actually point to virtual machine t-shirt sizes. From a technical perspective, it points to virtual machine characteristics. Now, when pointing to virtual machines, the list is getting pretty long, and that's why I provide you this URL here at the bottom of the slide. But overall, it's the general purpose machines, slower ones, cheaper ones, A0 to A4, the newer A version 2, and then the D1s all the way to D4s. Those machines are mainly used for development, testing purposes, low traffic servers, or even a slow database server if you want. Maybe a domain controller, or overall running machines where the performance isn't all that critical. The second category is computing optimized. It's the F, G, and H series, giving you a high CPU power to memory ratio, recommended for web servers and application service. The third category is memory optimized machines, D11 to D14 or the version 2 D11 to D50, giving you a high memory to core ratio, typically being used for database purposes. Really powerful machines, having a lot of memory, multiple cores, giving you a lot of power for running databases. The last one I want to cover here is the N series, specifically equipped with NVIDIA video graphical cards for providing you graphic capabilities, like hosting gaming servers, or 3D or overall video rendering like scenarios. That was about it around architectural side of virtual machines, where if you take it one step further, we can start deploying the operating system. I should already mention here that it's possible to upload your own custom images or even uploading pre-configured full system images provided by Microsoft or even third-party vendors. Azure supports Windows operating systems and a lot of different Linux operating system flavors. One important remark I can share here already is to always check the Azure operating system supportability matrix, making sure that the operating system you want to deploy is actually supported in Azure. Now, an operating system image is based on a pre-configured virtual machine setup, and it provides you with a custom image provided by the user. So imagine that you have your own custom image already available out of your own on-premises hypervisor infrastructure. Then you can easily upload this custom image. It needs to be a sysprepped generalized image, and then you can redeploy the virtual machine starting from that sysprepped image. And then one side note, the disk format also needs to be VHD. VHDX is not supported in Azure yet, and obviously VMware VMDK files are also not supported. VM images also require a disk, which at a minimum is an operating system disk, and then extending it with additional data disks depending on the workload of the server. And then giving the side remark that the number of data disks you can link to a virtual machine is depending on the virtual machine t-shirt size you selected before. One last remark regarding disks is the temporary disk. Whenever you create a VM, it will always receive a D drive, which out of Azure terms is a temporary disk. Compared to the virtual disk, this one is a physical disk in the Azure storage environment in the data center, natively mapping to data center storage components, which means it's not redundant when your virtual machine fails over to another physical rack. So keep in mind, you basically should never use the D drive for storing critical data, because when the machine fails over, you will lose the data on the physical D drive. So the recommendation would be to only use the D drive for temporary information, like a Windows page file, for example. This was about it as an introduction to the architecture of virtual machines. In the next video, I'll talk about provisioning and deployment of the virtual machine, and obviously walking you through several demos on how to make that possible.